Hi, my name is Vladan, and today I'm going to talk about charts. More specifically, in the part 1 of this lesson, I'm going to tell you more about charts description, understanding charts, and use of proper grammar to describe charts. In the part 2 of this lesson, I'm going to talk about using figures. That is, how to choose appropriate graph or graphs for your data, how to label and organize your charts and tables in your essay, reference for your figures. I will show you some good and bad examples of graphs use, and I will finish off by giving you some tips for graphs. So let's start. Part 1, Chart Description Builder, Understanding charts, grammar to describe charts. Chart Description Builder. To get important information from a graph, ask yourself the following questions. What exactly does the chart show? Use the chart title to help you answer this question. What are the axes and what are the units? What changes are there? How much did the variables change? What similarities are there? Is it possible to put some of the columns into one or more groups? What exceptions are there? Number 1. What are the axes and what are the units for graphs and charts? You do not have to include this information in your description, but asking yourself what are the axes and what are the units helps you avoid errors. For example, this x-axis shows time in years and the y-axis show population in millions. Are there any obvious trends? If there is an obvious trend, it is important to mention this. For example, look at our graph, population of Denmark. You can see from this graph that the population of Denmark increased steadily from 1996 to 2007. Are there any significant information? Look for obvious differences such as the largest or the smallest. Look at our graph of population of major European countries from 1997 to 2007. You can see that among major European countries, Turkey had the largest population increase from 1996 to 2007. Number 4. Are there any obvious exceptions to general trends? You will not normally see a graph with a straight line. Most line graphs will fluctuate in some way or another. Once you have identified a trend, point out the exceptions. For example, although the number of cinema goers increased from 1990 to 1998, there were slight falls in 1992 and 1995. What conclusions can you draw from the information presented in the graphs, tables, or charts? For example, it is clear from the information presented in these charts that internet use is increasing worldwide and will probably continue to do so as the price of the internet access falls. More on conclusions. Be careful not to draw conclusions which are not supported by the information in your graphs, charts, or tables. Here's a list of some useful expressions that you may use in your conclusion. Number 1, the data suggest or the data show. Number 2, the most significant fact is that. Number 3, in spite of this increase or in spite of this decrease, this could well be due to. This is supported by the fact that. An important point to note is that it is quite clear from this data that, and the last, the chart indicates that. Next, types of charts. Numbers and statistics can be shown in many different types of charts. However, for now, you need to know how to create, read and understand and describe these four basic chart types: bar chart, proportional bar chart, pie chart, and line graph, unless your instructor tells you otherwise. What I would like you to do next is to answer questions A and B on this slide. There is no handout for this task. Question A: match the four types of charts with the charts shown here. Number 1, bar chart; 2, proportional bar chart; 3, pie chart; and 4 is a line graph. Question B: which of the charts shows number 1, the situation at one point in time; number 2, change over time; number 3, how a total figure is divided into parts; number 4, comparisons for different groups; 5, how one value changes over time; 6, how several values change over time. Take 5 to 10 minutes to complete this task. Pause the video now. Okay, now here we have a solution. For question A, bar chart is figure B, proportional bar chart is figure D, pie chart is figure C, and line graph is figure A. For question B, answer 1 is B and C. Bar chart and pie chart show the situation at one point in time. Number 2, A and D. Line graph and proportional bar chart show change over time. However, bar charts can also be used to show change over time, but not in this example. Number 3, C and D. Pie chart and proportional bar chart show how a total figure is divided into parts. We could also include B if the chart shows all types of fruit sold that year. Number 4, B, C, and D. Bar chart, pie chart, and proportional bar chart show comparisons for different groups. Number 5, A. Line graph shows one value changes over time. And number 6 is D. Proportional bar chart shows how several values change over time. Next, look at the table or chart very carefully until you are sure what it shows and what it doesn't show. There are 3 important things to look at in a chart before you describe it. The title of the chart will tell you what is being shown overall, and it usually gives the time period that it represents. For example, from 1980 to 2000. Number 2, the titles of the vertical and horizontal axes will tell you what the units of measurement are. For example, centimeters, kilos, dollars, and what groups are being compared. Number 3, the key or legend, if there is one, will tell you what groups or time periods are shown. There is a hint. The titles and labels on the chart also give you useful vocabulary to use in your description. Describing a chart is similar in many ways to describing a table of figures. Remember that you have to do the following when you first look at a table. You need to check the dates to see what the time period is. You need to check what the units of measurement are. You need to decide what the most important information is. You need to decide what details are not so important. You need to make comparisons between important figures. You need to round figures up or down when possible. And you should do the same when you study a chart. More about dynamic charts and verb tenses. Some dynamic charts show a change in values from one time in the past to another time in the past. Other charts, however, may compare the past with the present. Occasionally, charts even show predictions about the future. In each case, you need to make sure that you are using the correct verb tense to describe the chart. For example, you could use present perfect. The price of oil has risen by 10 cents every month since January. Present perfect continuous. Average temperatures have been increasing since the beginning of the century. Future perfect. The population will have reached 60 million by 2030. Remember that it is important to use the correct time phrases with the tense you are using. Varying your tenses. In dynamic charts, you can sometimes vary your tenses. It is normal to stick to one tense, and it is good advice not to try too many variations, as you are likely to make mistakes. In dynamic charts, it is sometimes possible, however, to vary your tenses. Here are a few examples to show you how you may vary your tenses when describing charts. For example, the average price reached a peak of £127,000 in 2005 and then dropped slightly in 2006 and finished at £117,000 in 2007. There is nothing wrong with this, but to avoid and then problem, use the past perfect tense. For example, the average price finished the period at £117,000 after it had reached a peak of £127,000 in 2005 and fallen slightly the following year. This is the end of part 1 in today's lesson. Part 2, using figures. Figures can take many forms. They may be graphs, diagrams, photos, drawings, or maps. Think about your data and use some common sense to choose the most effective figure for communicating the main point. If you want your reader to understand spatial relationships, a map or photograph may be the best choice. If you want to illustrate proportions, experiment with a pie chart or bar graph. If you want to illustrate the relationship between two variables, try a line graph. Although there are many types of figures, such as tables, they share some typical features. For example, captions, the image itself, and any necessary contextual information, which will vary depending on the type of figure you use. Figure captions. Figures should be labeled with a number followed by a descriptive caption or title. Captions should be concise but comprehensive. Captions should describe the data shown, draw attention to important features contained within the figure, and may sometimes also include interpretations of the data. Figures are typically read from the bottom up, so captions go below the figure. Make sure that your figures contain proper captions positioned below the figure. Additional information. Tables and figures are numbered independently of one another. Also be sure to include any additional contextual information your viewer may need to understand the figure. For graphs, this may include labels, a legend explaining symbols, and vertical or horizontal tick marks. Look at the figure 1. There are two graphs, graph A and B, a line chart and a bar graph. They are properly labeled. Below, you can see the number of the figure and the caption. The caption gives important information on the variables used in the graphs. When you create your own graphs or tables, make sure that they are properly labeled with numbers and captions. Images. The most important consideration for figures is simplicity. Choose images the viewer can grasp and interpret clearly and quickly. You need to consider size, resolution, color, and prominence of important features. Figures should be large enough and of sufficient resolution for the viewer to see details clearly. Here are some quick references for figures. Figures should be, number one, centered on the page. They need to be labeled under the figure with the figure number and appropriate descriptive title. Figure can be spelled out or abbreviated, but you need to be consistent. Number three, figures need to be numbered in the order they appear in the text. This is very important. And figures need to be referenced in the order they appear in the text. For example, figure 1 is referenced in the text before figure 2, and so forth. Graphs. Every graph is a figure, but not every figure is a graph. Graphs are a particular set of figures that display quantitative relationships between variables. Some of the most common graphs include bar charts, frequency histograms, pie charts, scatter plots, and line graphs, each of which displays trends or relationships within and among datasets in a different way. You'll need to carefully choose the best graph for your data and the relationship within the graph that you want to show. Some good advice regarding the construction of graphs is to keep it simple. Remember, the main objective of your graph is communication. If your audience is unable to visually understand your graph, then you have failed to communicate the information contained in your graph. Pie charts. Pie charts are used to show relative proportions, specifically the relationship of a number of parts to the whole. Use pie charts only when the parts of the pie are mutually exclusive categories and the sum of parts adds up to a meaningful whole, 100% of something. Pie charts are good at showing big picture relationships. For example, some categories make up a lot or a little of the whole thing. However, if you want your reader to notice fine distinctions within your data, the pie chart is not for you. People tend to prefer length, so try a bar chart as an alternative way to show relative proportions. Additionally, pie charts with many little slices or slices of very different sizes are difficult to read, so limit yours up to 7 categories. Here are some examples of bad pie charts. In figure 2, we can see that there are many categories. As I mentioned earlier, for the pie charts, limit your categories up to 7. In the figure 2, we can see that the sum of all parts does not add up to 100%. Make sure that you do not exceed 7 categories and that your pie chart add up to 100%. Bar graphs. Bar graphs are also used to display proportions. In particular, they're useful for showing the relationship between independent and dependent variables, where independent variables are discrete, often nominal categories. Some examples are occupation, gender, and species. Bar graphs can be vertical or horizontal. In a vertical bar graph, the independent variable is shown on the x-axis, left to right, and the dependent variable on the y-axis, up and down. Make sure that your axes are properly labeled. In a horizontal one, the dependent variable will be shown on the horizontal x-axis, the independent on the vertical y-axis. The scale and origin of the graph should be meaningful. If the dependent numeric variable has a natural 0 point, it is commonly used as a point of origin for the bar chart. However, 0 is not always the best choice. You should experiment with both, origin and scale, to best show the relevant trends in your data without misleading your audience in terms of the strength or extent of those trends. XY line graphs. Line graphs plot a series of related values that depict a change in one variable as a function of another. For example, world population is a dependent variable over time, which is an independent variable. Individual data points are joined by a line, drawing the viewer's attention to local change between 2 points and overall trend. Line graphs are similar to bar graphs, but are better at showing the rate of change between 2 points. Line graphs can also be used to compare multiple dependent variables by plotting multiple lines on the same graph. General tips for graphs. Strive for simplicity. Your data will most likely be complex, and your job is to communicate the most important point about your data. Think of graphs like you think of paragraphs. If you have several important things to say about your data, make several graphs, each of which highlights one important point you want to make. Strive for clarity. Make sure that your graphs are visually clear. Make sure that you have described the elements of the graphs clearly. Ask yourself if your audience will be familiar with your figures, and if not, you may need to explain your figure in the text. Redundant elements may make graphs visually confusing. Your audience may not want to spend a lot of time to figure out the point of your graph. Accuracy. After you finish your graph, carefully check for any errors. Even a simple graphical error can change the meaning and interpretation of your data. Do not manipulate your data so that it looks like it's saying something it's not. How should tables and figures interact with text? Number 1, you may put tables and figures on separate pages from the text, as near as possible to the place where you first refer to it. You can also put all the figures and tables at the end of the paper to avoid breaking up the text. Figures and tables may also be embedded in the text as long as the text itself isn't broken up into small chunks. Complex raw data is conventionally presented in an appendix. Please note to check with your instructor for the placement of figures and tables in your essay. Next, when referring to tables and graphs from within your text, you can use clauses beginning with as, for example, as shown in Table 1. You may use passive voice. For example, results are shown in table 1. Or you may use active voice. For example, table 1 shows that. Or parentheses, each sample tested positive for 3. Now, this is the end of the chart series. By now, you should be able to use your data to create a graph or graphs, to describe your data using proper structure, introduction, body, and conclusion, to use proper grammar, simple tenses for static charts, progressive and simple tenses for dynamic charts. You should also be able to properly label, position, and reference your graphs or tables in your essay. And you should be able to describe your graphics clearly and accurately. Thank you for your time. Goodbye.